Hi students and friends, welcome to the channel Learn and Teach by Sir Ayaz. I hope you all are fine and enjoying good health. I will continue the topic simple molecules and covalent bonds with the solution of the question I have asked about dot and cross diagram in the last video. Here's a question: draw dot and cross diagram to show the electronic configurations between hydrogen and bromine. Recall the valencies of hydrogen and bromine. You know the formula between these two will be HBr, which means there is one atom of hydrogen and one atom of bromine. I will show dot for the valence electrons of bromine and cross to show the valence electrons of hydrogen. Bromine belongs to group 7, which means it needs one electron to complete its valency, and we know that hydrogen needs one electron. So final diagram, dot and cross diagram between these two will be like this. This is bromine, this is hydrogen, HBr. First of all, I'm going to show the valence electrons of hydrogen, which is 1. Now let's show the valence electrons of bromine, which is 1, 2, 3, 4, 5, 6, 7. You see, both have completed their valence shell. Bromine got 7 electrons, as it belongs to group 7. So it has shared one of its electron with one electron from hydrogen. Let's count the electrons for bromine. 1, 2, 3, 4, 5, 6, 7, 8. And for hydrogen, it needs one electron to complete its valence shell. This one belongs to hydrogen, and this one is coming from bromine. So it has also completed its valence shell. Let's do the next one. Carbon and sulfur. These two will form the compound, the formula CS2. Or recall the dot and cross diagram of CO2, then it will become easier for you to draw the final diagram. I'm showing the dots for sulfur and cross for carbon. We have carbon in the middle. That's carbon. This is sulfur number 1, sulfur number 2. SCS. Now let's show the valence electrons of carbon. There are 4 electrons in carbon as it belongs to group 4. 1, 2, 3, 4. Now start placing the electrons of sulfur. It belongs to group 6. There should be 6 valence electrons. 1, 2, 3, 4, 5, 6. For the next sulfur, it will be 1, 2, 3, 4, 5, 6. If you count the total number of electrons in each circle, it will be 8, which tells that all these 3 have completed its valence shell. 1, 2, 3, 4, 5, 6, 7, 8. This one is for the sulfur. For the next sulfur, 1, 2, 3, 4, 5, 6, 7, 8. Now let's count the electrons for carbon. 1, 2, 3, 4, 5, 6, 7, 8. So all these 3 have completed their valence shell. Now we'll continue the lesson with the same learning outcome, which is to describe the formation of covalent bonds in simple molecules, including a molecule starting from H2 and ending on N2. Use dot and cross diagrams to show the electronic configurations in these and similar molecules. For your convenience, here's the periodic table so that you can recall the valencies of non-metals also. Only I'm writing the valency from group 4 till group 7 valencies. Group 4 plus minus 4, group 5 minus 3, group 6 minus 2, group 7 minus 1. These are the valencies. Now, in this lesson, I will talk about the different types of covalent bonds on the basis of the number of electrons they share. Let's start with single covalent bond. Single covalent bond involves the sharing of only two electrons of one pair of electrons between two atoms. Single covalent bond involves the sharing of only two electrons or one pair of electrons between two atoms. Here's some examples of molecules containing single covalent bonds. Perfect example is H2O. I will show the displayed formula as well as dot and cross diagram so that you have better idea about single covalent bonding in H2O. Here's a dot and cross diagram between oxygen and hydrogen in water. This is water. It's hydrogen, oxygen, hydrogen. I'm using dot for oxygen here. 1, 2, 3, 4, 5, 6. Hydrogen. 1, 1. You see only one pair of electrons are shared. So the displayed formula for this will be like this. HOH. This indicates only one pair of electron is shared. Single dash line means only one pair of electrons are shared. What are double covalent bonds? A double covalent bond involves the sharing of only 4 electrons or 2 pairs of electrons between two atoms. It involves the sharing of 2 pairs of electrons or 4 electrons between two atoms. Some examples of the compounds containing double covalent bonds. We have O2, CO2, etc. Now I'm showing you the dot and cross diagram as well as the displayed formula so that you have better idea about double covalent bonding in O2 and CO2. For O2, it will be like this. Each oxygen atom needing 2 electrons to complete the valence shell. First of all, I will show the valence electron for this one. 1, 2, 3, 4, 5, 6. For this oxygen, 1, 2, 3, 4, 5, 6. You see 2 pair of electrons are shared. So the displayed formula for oxygen molecule will be like this. O double bond O. What about CO2? This is oxygen, carbon, oxygen, oxygen, carbon, oxygen. First, I will show the valence electron of this oxygen. 1, 2, 3, 4, 5, 6. This one, 1, 2, 3, 4, 5, 6. Now we are left with the valence electrons of carbon. So this will share 2 electrons with each oxygen atom. 1, 2, 3, 4. The displayed formula for the carbon dioxide will be like this. O double bond C double bond O. This indicates that 2 pair or 4 electrons are shared between carbon and oxygen. Triple covalent bond, it involves the sharing of only 6 electrons or 3 pair of electrons between two atoms. It involves the sharing of only 6 electrons or 3 pairs of electrons between two atoms. Let's see the example. Perfect example is N2, nitrogen molecule. Each nitrogen atom needs 3 electrons to complete its valence shell. So both will offer 3 electrons to each other to complete their valence shell. The dot and cross diagram. Let's draw the valence electron for this nitrogen. 1, 2, 3, 4, 5. For this one, 1, 2, 3, 4, 5. There are 3 pair of electrons are shared. So I'm going to show it in this way, 3 dashed lines. So this dashed line indicates that 3 electrons are shared in this nitrogen molecule. So here's the summary of today's lesson. Single covalent bond involves sharing of either 2 electrons or 1 pair of electrons. Double covalent bond involves sharing of either 4 electrons or 2 pairs of electrons. Triple covalent bond involves sharing of either 6 electrons or 3 pairs of electrons. Thanks for watching. Press like, give comments, and share my video. For more videos, subscribe my channel and press the bell icon.